Hello students, in this lecture we will see the second numerical on mesh analysis. So the problem statement is to determine current through 5 ohm resistor using mesh analysis. So first of all one has to identify the number of meshes. So it is quite clear over here that there are 3 meshes. So this is mesh 1 and I am assuming current through that one as I1 in clockwise manner. In the last lecture I have mentioned that we prefer the currents in the consistent direction. That means either you prefer all the currents to be in clockwise manner or anti-clockwise manner. Here I am assuming all the 3 currents in 3 meshes in clockwise manner. So I have assumed I1, I2 and I3. Now you have to apply KVL in each mesh and you have to obtain 3 equations. So KVL in mesh 1. But before applying KVL in each mesh 1, you need to assign the sign for the voltages. So when you are traveling this loop in a clockwise manner, I1 you are giving preference to I1. So I1 enters over here, so positive over here and negative over here, positive over here and negative over here. So I am applying KVL over here and I will write down leaving sign for the voltages. So here this is plus 8. So I am writing 8 over here minus 1 time, and you have to 1 ohm is shared between mesh 1 and mesh 2. So the net downward current is I1 minus I2. Go ahead, minus 2 times 2 ohm is shared between mesh 1 and mesh 3. You have to write down net leftward current because you are applying KVL in mesh 1. So here we will have I1 minus I3 and this is equal to 0. You have completed the loop. So here it is 8 minus I1 plus I2 minus 2I1 plus 2I3 is equal to 0. So I will write down these terms in nice format. And what do you mean by nice format over here is I will prefer coefficient of I1 to be positive since I have applied KVL in mesh 1, and this turns out to be 3 times I1 minus 1 I2 minus 2 I3 is equal to 8, and this is my equation number 1. I prefer to be coefficient of I1 to be positive, so I have transferred these terms I1, I2, I3 on RHS and I have made the coefficient of I1 as positive. Next, KVL in mesh 2. So KVL in mesh 2. Before that, we have to assign the sign for the voltages developed across the resistances. So plus, minus, plus, minus, plus and minus over here. I am starting the terms or KVL starting apply from this end. So here I will have 10 minus 4 times I2. You go ahead, minus 3 times 3 ohm is shared between 2 and 3. So the net current will be I2 minus I3 towards left. 1 ohm is shared between mesh 2 and 1. So the net upward current is I2 minus I1. And you have completed the loop, so is equal to 0. So these terms are 10 minus 4I2 minus 3I2 plus 3I3 minus I2 plus I1 is equal to 0. I will arrange the terms in such a manner that I will have a nice format, and in that the coefficient of I2 will be positive. So this turns out to be minus 1 time I1 plus 8I2 minus 3I3 is equal to 10. This is my equation number 2. Now KVL in mesh 3. So KVL in mesh 3. But before applying KVL, you need to assign the sign for the voltages developed across the resistances. So you are traveling this loop mesh 3 in a clockwise manner. Current enters positive side, it leaves negative side over here. So plus, minus and plus, minus. So signs has been assigned for the voltages. Now I will write down the terms over here. Every term should be voltage over KVL. So every term should be voltage. I am starting at this point. So here I will have 12 over here minus 2 times I3 minus I1. We are traveling towards right through 2 ohm minus 3 times I3 minus I2, and then you have minus 5 times I3, and you have completed the loop, so is equal to 0. So this turns out to be 12 minus 2I3 plus 2I1 minus 3I3 plus 3I2 minus 5I3 is equal to 0. Now I will prefer write down the equation in nice format, and here nice format means the coefficient of I3 I will prefer to be positive. So this equation turns out to be, or these terms rearrangement leads to minus 2 times I1 minus 3 times I2 plus 10 times I3 is equal to plus 12, and this is my equation number 3. Now I will write down these three equations in matrix format. So I will have from equation number 1 3 minus 1 and minus 2, 3 minus 1 and minus 2 from equation number 1. Here you will have I1, I2 and I3, and the right hand side is 8. From equation number 2 I will have minus 1, 8, minus 3 and 10, and here I will have minus 2, minus 3 and plus 10 over here, and the right hand side is plus 12. So what is the advantage of writing these three equations in nice format? And first of all, what do you mean by nice format? When you are applying KVL in mesh 1, prefer the coefficient of I1 to be positive. Mesh 2, coefficient of I2 to be positive. So we have to arrange the terms in such manner. I3, coefficient of I3 is positive. So if you see this carefully, this is nothing but resistance matrix into current matrix is nothing but voltage. So we are basically writing Ohm's law over here. So the matrix is symmetric. And what do you mean by a symmetric matrix? I'm talking about mathematics. So Aij is nothing but Aji. So any element of the matrix satisfy this criteria. So you can see here first row second element minus 1 over here, second row first element over here, first row third element and third row first element, they are same, and then you have second row third element and third row second element, they both are same. So that is the advantage of writing these equations in nice format. Okay, one can easily verify this. Even one can check this thing. You add all the resistances in mesh 1. So here 2 plus 1, mesh 1, I'm talking about mesh 1, 2 plus 1, 3. So that is nothing but these 3 over here. You add all the resistances in mesh 2, you will have 8 over here. And you add all the resistances in mesh 3 over here. So that leads to 10. So they are forming the diagonal entries of this resistance matrix. And one can easily check the shared resistance values are turning out to be at their places. So here first row second element, so first row first mesh and second mesh, they are sharing 1 ohm over here, so that's why minus 1 ohm is over here, because the currents through 1 ohm are in opposite direction. I1 is moving downward, I2 is moving upward, that's why minus 1 over here. Similarly mesh 1 and mesh 3, they share 2 ohm resistance over here, and current through 2 ohm, they are opposite. So I1 is moving towards left, I3 is moving towards right, that's why there is a negative sign. You have to enter these coefficients in calculator, and you have to obtain 3 unknowns. You have to find out 3 unknowns, and this is the fair thing because we have obtained 3 equations and there are 3 unknowns. So I1 turns out to be 6.013 ampere, you can check this thing. I2 turns out to be 3.27 ampere, and I3 turns out to be 3.384 ampere. But the problem is not over here. We have to calculate current through 5 ohm resistor. So current through 5 ohm resistor, here I am writing current through 5 ohm resistor is nothing but 5 ohm is over here. It is present exclusively in mesh 3. So that is nothing but current through that one is nothing but I3. This is not shared with any of the mesh. So it is nothing but I3, and that means it is towards left. And so it is 3.384 ampere. We have to mark the proper sign for the direction, proper direction of the current over here. Current through 5 ohm is towards left. Okay. Now suppose they are asking you for the same numerical, they are asking you to calculate current through 1 ohm resistor, and 1 ohm is shared between mesh 1 and mesh 2. So just I will copy the values of I1, I2, I3. So I1, I2, and you have I3 over here. Okay, I1 turns out to be 6.013 ampere, I2 turns out to be 3.27 ampere, and I3 turns out to be 3.384 ampere. Now through 1 ohm, you have to calculate current through 1 ohm. So you decide how you have to move, either downward or upward. If you have decided to move downward, then the net downward current is nothing but I1 minus I2. And here I will write down downward. I will mark that direction of the current. So this turns out to be 6.013 minus 3.27, and that current is moving downward. So this leads to 2.743 ampere downward. So this is the current flowing through 1 ohm resistor. If you would have chosen upward direction, don't look at these values. If you would have chosen the upward direction, then the net current would have been I2 minus I1, but that will turn out to be negative. So one can make it positive by changing the direction. So that is all about numerical 2. Thank you.